Hey y'all, in this lesson, we're going to be talking about permutations. So we're going to be learning about how you can recognize what a permutation is, and then also how to calculate it by hand and using a calculator. To get us introduced to permutations, let's talk about this example just to get started. So 5 friends, Brooke, Peyton, Haley, Lucas, and Nathan. If you've ever watched One Tree Hill, you know who I'm talking about, want to take a photograph together for the yearbook. So we've got 5 classmates, they want to take a photo. The question is, how many ways can the friends arrange themselves in a row for the photograph? So we're going to take into consideration the places. We'll call, place 1, 2, 3, 4, 5. And then we're going to kind of use the fundamental counting principle to translate into permutations. So in the first position, we have 5 options. There's 5 classmates, we have 5 options. Now, if one classmate stays there, then for my next position, we have 4 options, 3, 2, 1, or we could write this as 5 factorial. And that is going to come out to 120. So there's 120 ways that these students, these classmates can arrange themselves for the photograph. Now, if we have 5 friends, but we just want to have 3 of them in the photograph, then now there's only 3 positions, 5 options for the first position, 4 for the second, 3 for the third position. It's hard to say. So now there's only 60 ways that they can arrange themselves. This second question gets us into the idea of how many arrangements are there if the total is 5 items or 5 classmates in this particular instance, and we only want 3 of them to be in the photo, get the photo taken of them. And this idea is a permutation where there's 5 objects and we want to take only 3 of them to arrange them in different ways. And in this particular instance, the order of the arrangement matters. So you might see permutations written as a little n down here, P, big P, little r. N represents the total, and R represents the objects selected. You might also see this written like this instead, with the N would be at the top and R would be at the bottom. I noticed when I was making this document, this was my only option for typing that in. They didn't offer me this. So I usually write it this way, but this is also safe. And then the formula for finding permutations is if you're given N for the total, R for the objects selected, number of objects selected, the formula for finding the number of permutations is N factorial over N minus R in parentheses, that matters, factorial. So this difference represents basically what's left over. So up here, when we have 5 take 3, we ended up just doing 5 times 4 times 3. And I'll show you that later. We'll get into that. I'm getting excited. Okay, so these are going to be very straightforward. They're not word problems yet. We're just going to practice using the formula. So we have this 4p2, and this represents N, this represents R. And all we have to do is just plug it into the formula. So permutation of this equals N factorial over N minus R factorial, parentheses matters. So I'm going to simplify inside the parentheses, 4 minus 2. Now I can drop the parentheses because I've simplified it already. And then we know how to do this by hand. 4, 3, 2, 1 over 2, 1. And then we have these divide. So we end up with 4 times 3, which is just 12. So if we had a situation where 4 classmates wanted to take a picture and we only chose 2 at a time, or only had room for 2 at a time, then you would have 12 different ways to arrange the two classmates. Okay, I want you to pause and try these two with the formula. And that formula is up here in case you need it. And then pause it, try it, come back and check your work. Okay, here are the answers for those two problems. 8 choose 5, you end up with 6,720. And then 5 choose 5, you end up with 120. Now I want to use this last example to go back to what I was talking about earlier where I stopped myself. So if we have 5 classmates and we want 5 of them to be in the picture, then we end up with 120 because this relates back to this concept here. 5 friends, 5 places means that we don't have to leave anyone out. So it ends up looking like that. And also one key thing I want you to remember there is that 0 factorial is 1 because the number of ways that you can arrange an empty set is just one way. So if you missed that in my last video, there's that. And then I also want to talk about, I had introduced the idea of 5 choose 3 and why that was a permutation. I want to show you that with the formula. So what happens here is we have n factorial over 5 minus 3 factorial. And then what happens here is when we write this out, when we expand it out, whoops, the 2's and 1's divide, simplify to 1, and we're only left with the 5, 4, 3. So that hopefully you can relate that to if there's 5 people and we're only choosing 3, then we're kind of not canceling out, because we don't say canceling out, but we're discounting, we're eliminating the 2 that can't be in there. And so you have 3 positions, 5 people, 5, 4, 3. So hopefully that helps you kind of make a connection there between the two. And then this one, if we have 8 positions and we're choosing 5, then we are eliminating 3, and that's where that 3 comes from. And then those 3, 2, 1s in the numerator and the denominator end up dividing to 1 or simplifying to 1. And so that's why I only wrote 87654 and you get 6,720. So now that we know how to do it by hand, which is great, and that's going to help us in our next video when I talk about combinations. But now that we know how to do it by hand, obviously I want to show you how to do this in the calculator because sometimes these numbers can get really big, really fast. So whenever you're working with factorials, that's, if you got 100 items or 100, positions or whatever, that's a lot to write down. So in those cases, it's going to be a little bit better to just use the calculator. And I have the steps here to do that. I used the 4 choose 2 example here. And here's what it's going to look like in your calculator, depending. It also may look like bigger font like this, depending on, I think my calculator on this iPad is like that, but I'll show you. But the key here is that you have to type in the 4 first, or in whatever n is first. Then you're going to go to math, over to probability. You're going to pick the one you want, then type the 2 last, and then hit enter. I'm going to walk you through it because I don't want you to be confused. So it's 4 choose 2, which means I have to start with 4. 4, go to math, over to probability, and under the probability menu is NPR. And then mine pulled up the template, so I was wrong. It didn't do the bigger font like I thought. And then the R value is 2. Hit enter, and there's that 12, which is what we got when we did it by hand. Yay! So now I want you to practice using the calculator and do these problems down here. So pause it, try it, come back. Okay, so hopefully you can see I've got my calculator pulled up on the right. And notice that all of those have a P, not a C. C is something different. I'll talk about it in my next video, but these all should be P's, so just be careful with that. And then on your first one, you're going to get 151,200. There's that big number I'm talking about where doing it by hand might be a pain. And then on the next one, 28, choose 0. There's only one way you can choose 0. And then this last one, look at that number. That is a huge number. So that is, depending on your calculator, it may have given it to you in scientific notation. So yours may have looked a little bit different than mine. I have my settings to where it's floated to more decimal places. So depending on your calculator, you can change those settings. I believe that's in the mode. Mine's going to look different here, but you can change. I think it's, well, I can't remember which setting it was, but here's in mode, you have settings here, and float is referring to like how many decimals, I believe. Anyway, not the point, but let's go back here. So I promised that I would talk to you about when we use permutations. So I do want to talk about that. Permutations are used when repetition is not allowed and order is important. So what do I mean by order is important? If you were running a race, let's say, or competing in a tournament, whatever, if you were running a race, then don't you think that if you got first place, that would matter? I mean, I think it would. Or if you got second place or third place or fourth place or whatever, that place matters. It's not like, oh, top 6, it doesn't matter that you got first, we'll put you in a 6th place. You'd be like, no. So in situations like that, where order is important, we're using permutations. So if you're talking about a race or a tournament or officers of a club, so not just like leaders of a club, but president, secretary, vice president, reporter, all those things where you have a specific title, those are types of situations we're going to use permutations. Some other examples are license plates, order matters. MWB is not the same as WMB. So those would be 2 different license plates. Account numbers, like bank account numbers. Officers of a club. Places in a race, or scheduling, like scheduling classes or anything like that. So anything like that where there are specific places for specific objects, that's going to be a permutation. And this is really silly and pretty old school, but I kind of remember it when I was learning this. I kind of used to remember it with back in the day, way back in the day, we used to get perms, and the order in which you applied the chemicals to your head, so unsafe, but applied the chemicals to your head mattered. The order of a perm matters. So order matters in permutations. I don't know. That's kind of a silly example, but it's what I use to remember the difference between permutation and combination, because they are different. So let's see. 7 people are running for office in the math club. How cute. There are 3 officer positions: president, secretary, treasurer. How many ways can 3 people be chosen from the 7 people? So first, when we read this, we need to decide, is this a permutation or a combination? And obviously, since this lesson is over permutations, it's not going to be a combination, but I want you to be able to narrow that down further if you are given lots of different examples and you have to choose whether it's permutation or combination. So this one very clearly is permutation because of these words here. Those are specific positions, which means that order matters. That's the wording we use. The order matters, and there's no repetition. A person can't be both a president and a secretary in this particular instance. So this is going to be a permutation, which means we have to use this formula, or if you're using your calculator, you have to use the NPR. And there are 7 total people running, and we're choosing 3. And so if you're doing it by hand, you would do 7 times 6 times 5. Or I guess you could have even done, there's 3 positions, 7 options, 6 options, 5 options, same thing. Or your calculator. I always love to give you lots of options. Obviously, whatever way you see it in your mind, I am happy. So I just did, to pull that back up because I'm tired of going to math, probability, NPR. I did second enter and it just pulled up my previous entry. And I'm going to scroll over and hopefully it's going to let me do this. Yeah. And we're choosing 3 people. Yeah, we're choosing 3. 7, choose 3, enter, 210, and then I can just check that out. 7 times 6 times 5. Yeah, so I know that's right. That's the advantage of doing it or knowing how to do it several ways, is you can go in and check yourself just in case, especially if it's a test. Okay, this next one is really cool. A very popular problem in the world of mathematics. Suppose license plates are being created. They want 3 non-repeating. This is a key word, non-repeating. This indicates permutation. And I know that this lesson is only about permutations, but you will have problems mixed up together and you're going to have to choose. And in order to choose, you have to look for those keywords, non-repeating, followed by 4 non-repeating, again important, numbers. How many license plates can be created? So we kind of have 2 different situations going on here, and we're going to focus on each part separately and then deal with them together at the end. So in the first instance, we're talking about letters. How many letters are there in the English alphabet? 26. And we are choosing 3 non-repeating. So this is going to be 26 letters, and we're choosing 3 permutation. And I can use my calculator for that. Now we can talk about numbers. How many numbers are there that can be used on a license plate? Now remember, 0 is a possibility as a number. We don't need to go as far as 10 because 10 is 1 and 0. We're just talking about 1-digit numbers. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we stop at 9 and we include 0, that's 10 numbers that we get to choose from. So I know that's kind of a weird concept because we're stopping at 9, so you think, oh, it's 9 numbers. But if we start at 0, then that's 10 numbers that we get to choose from. 10. And we're choosing 4. So I'm going to go here, 10, choosing 4. I can use my calculator. And then your last step is you're going to be multiplying those 2 instances, those 2 situations. I'm using the wrong words here, but hopefully you're getting what I'm talking about. You're going to multiply those together because we're multiplying all these options together. And I'm going to just, if you pause it, put that on your calculator, multiply them together and come back. Okay, so hopefully after you figured these out and multiplied them, you got 78,624,000 different license plates. That's a lot. So we did each part separately and then we just multiplied them together. You could have typed it in as one step if you wanted to, where you do 26, choose 3 times, and then the other one, and that would just be one step instead of the 3 different lines. That is all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know and I'd be happy to help. I'll see you in the next one where we talk about combinations.